Whenever a message travels through a medium, it is targeted by a fundamental law of the universe: noise. In a computer network, noise is a literal corruption of data. A single flipped bit, 10 turning into a 1, is enough to compromise a 63-bit block, turning a precise command into a cascading failure. Human interaction follows a similar logic of degradation. A poorly worded sentence, a distracted glance, or speaking too fast functions like that flipped bit, distorting the intended meaning before it ever reaches the listener. Without a way to detect and resolve these inevitable errors, complex systems fail, computer networks crash, and human communities lose the ability to coordinate. Correcting a mistake is impossible without first identifying it, and a high-functioning system must find the error without discarding the entire transmission. Engineers use a checksum, a mathematical fingerprint, to verify data integrity. This chart of digits on a credit card is validated by the Loon algorithm to catch typos. By performing operations on alternating digits, the resulting sum must always be a multiple of 10. If not, the system knows the transmission was corrupted. Human error detection requires a similar commitment to signal clarity. To accurately receive a message, the listener must first eliminate external noise, such as gossip or preconceived notions. Prophet Muhammad established a protocol for this kind of high-fidelity reception. He would turn his whole body to face a speaker, offering total focus and listening until they were completely finished before offering a response. True detection, whether in an algorithm or a conversation, requires this level of undistracted attention to isolate the error without breaking the connection. When a system detects a mistake, the standard response is blunt correction. The computer rejects the corrupted block and demands the sender transmit the entire message again. This creates a massive bottleneck, slowing the entire network to a crawl. We often apply blunt correction to each other. When someone makes a mistake, we react with anger or shame, effectively demanding they start over, while the relationship suffers the lag of that confrontation. There is a more efficient mathematical alternative: the Hamming code. The Hamming code uses built-in redundancy called forward error correction. It analyzes the data on the fly, mathematically isolates the specific bit that flipped, and instantly corrects it while the transmission continues. Advanced systems move beyond simple alerts. They are engineered to repair the error and keep the data moving forward gracefully. Prophetic strategies for social correction mirror this concept of forward error correction, repairing mistakes without requiring a total relationship reset. When a Bedouin man committed a grave social error inside the Prophet's mosque, the crowd reacted with blunt force. The Prophet de-escalated them, corrected the man with gentleness, and provided a solution without using shame to demand a restart. He also realigned errors in logic through empathy. When a young man publicly sought permission for a transgression, the Prophet didn't respond with threats. He used analogies about the man's own family to help him arrive at the correct conclusion himself. He even optimized for human bandwidth, carefully timing his advice and spacing out his corrections to avoid boring or overwhelming his listeners. This approach repairs the immediate mistake, while simultaneously preserving the integrity and the dignity of the person involved. Computational logic and social ethics intersect at the need to preserve the signal against the noise of a flawed channel. Both fields prioritize the long-term integrity of the system over the momentary impulse to be right. In the city of Mecca, this commitment to reliability earned Prophet Muhammad the title of Al-Amin. Al-Amin means the trustworthy. It described a person whose character provided absolute security, someone with whom valuables, secrets, or lifelong hopes could be deposited without any fear of them being corrupted or lost. We engineer computer networks to protect raw data from falling into disorder. We have a similar responsibility to engineer our human interactions to protect human dignity from the same decay. True integrity means accepting that errors are an inevitable part of transmission, but choosing to correct them with maximum efficiency and minimum destruction.